So next we can look at alcohols. So alcohols have what's known as the hydroxyl group. And so the naming convention for this is putting the suffix of "ol". So for example, ethanol being a molecule which has got 2 carbons, it's just a general ethane molecule, except one of the hydrogens has been replaced by the hydroxyl group. And so the general structure is an R group, so an R group being any alkane, alkene, alkyne chain, with then a hydroxyl group attached to it. And so we've got 3 different classes of alcohols, or types of alcohols, and so these are known as primary, secondary, and tertiary. So primary alcohols are going to be alcohols in which the carbon atom, which is bonded to the hydroxyl group, is only bonded to one other carbon atom. So for example, or no other carbon atoms. So for example, with our primary alcohol here, we've got methanol, and so methanol, the carbon atom which the hydroxyl group is bonded to, is not bonded to any other carbon atoms. So methanol being the one and only exception. Ethanol would also be a primary alcohol, as we can see that the carbon atom which is bonded to the hydroxyl group is only bonded to one other carbon atom. Next, we can look at the secondary alcohols, where the carbon atom bonded to the hydroxyl group is bonded to 2 other carbon atoms. So an example of this would be something like this one here, which would be 2-propanol, and so that's saying that we have a 3 carbon chain long molecule, and on the second carbon along there is a hydroxyl group, making it a 2-propanol molecule, which is a secondary alcohol. And this is because the carbon which the hydroxyl group is bonded to 2 other carbon atoms. And so if this hydroxyl group was to be bonded on the first or last carbon atom, and hence making it 1-propanol, it would then become a primary alcohol, because if it was bonded to the first or the last carbon, the carbon which the hydroxyl group was bonded to would only be bonded to one other carbon. Then finally, we've got tertiary alcohols. So tertiary alcohols have a carbon atom which is bonded to the hydroxyl group being bonded to 3 other carbon atoms. And so typically this will only occur if you have a some kind of branch, like a methyl group or an ethyl group, on the same carbon that the hydroxyl group is bonded to. So for example, this molecule here being methyl propan 2-ol, so saying that we've got a methyl group on a propanol molecule and a hydroxyl group on the second carbon into the propanol molecule. And so that's because this carbon here is bonded to the hydroxyl group, and it's also bonded to 1, 2, 3 other carbon atoms, hence making it a tertiary alcohol, because the carbon with the hydroxyl group bonded to it has the carbon bonded to 3 other carbons. So some examples which we have of alcohols is propan 2-ol or 2-propanol. So these are 2 different ways which you could name this particular molecule. I would say the best way is the first name, so the propan 2-ol, just because that makes it very clear and very explicit that you are naming the alcohol as being on the second carbon along the chain, whereas with more complex molecules, when they become very complex and you put the 2 out the front and make it 2-propanol, that makes it very difficult to follow what the numbers are actually naming. So I would preference calling it propan 2-ol as opposed to 2-propanol. But they are both correct ways which you can name this molecule. And so when we look at this molecule, we can see that the reason that it's called propan 2-ol is because we've got a propane chain, so 3 carbons along the carbon backbone. And then we can see that on the second carbon along, we've got a hydroxyl group as opposed to a hydrogen. And so this is what makes this propan 2-ol. So the 2 denoting that it's on the second carbon, and the ol suggesting that it's a hydroxyl group. The next one we can look at is ethane 1,2-diol or 1,2-ethane diol. And so this one's employing our supplementary IUPAC rules. And so it's saying that we've got 2 hydroxyl groups in this ethane molecule. So I would say name it with the first name which I've got here, which is ethane 1,2-diol, because this specifically shows that the 1,2 is specific to the alcohol groups, whereas if this was a more complex molecule, it could easily get muddled up with putting the numbers out the front. So we can see that on the first carbon, we've got a hydroxyl group, and on the second carbon, we've also got a hydroxyl group, hence making this ethane 1,2-diol, the di meaning that there is 2 hydroxyl groups in this particular molecule, and the 1,2 suggesting that it's on the first carbon and on the second carbon. The next class of molecules we can look at is aldehydes. So aldehydes have what we know as the end chain carbonyl group, so that being a double bonded oxygen. And so our example which we have for these is ethanal. So ethanal being this molecule here down the bottom, where we can see we've got 2 carbons, making that the ethane part of the name. And then we can see instead of having 3 carbons on the second carbon in the chain, we've got 1 carbon and a double bonded oxygen instead. And so that end chain carbonyl group meaning the double bonded oxygen group. And so the general structure of an aldehyde is that they will have an R chain, so any alkene, alkane, alkyne type chain, followed by the final carbon on the chain having a double bonded oxygen and a single bonded hydrogen. So some examples which we have of these is butanal. So butanal being this molecule here, where we can see we've got 1, 2, 3, 4 carbons along the main chain, that being the butane part of the name, and then we've got the double bonded oxygen and single bonded hydrogen on the end of this molecule, making this known as an aldehyde molecule because the carbonyl group is on the end of the molecule. So that is butanal. The next one we're looking at is propanal. So similar concept, except we've got a propane chain as our main chain. So 3 carbons along the main carbon backbone, and then completed with an oxygen group, a double bonded oxygen group on the end of the molecule. So that being our carbonyl group there, making it a propanal molecule as opposed to our normal propane molecule.